Composite figures. How do you find the area of composite figure, of a composite figure? As always, remember, as we go through the vocabulary and every example, you have the ability to pause so you can write it down at your own speed and come back and join us when you are done. A composite figure, it's a shape that can be divided into more than one of the basic shapes. I usually think of an ice cream cone, which is a triangle and a semicircle, or a house, which is some sort of square or rectangle with a triangle on top. That would be a composite figure because it's made up of more than one figure. We also have a sector. A sector of a circle is just part of the circle. The technical definition is the portion of a disc enclosed by two radii and an arc. Really, all it means is it's just a fraction part of a circle. If I found the area of the whole circle and then divided it to get just this part, I have the sector of the circle. All right, so today we are going to work on finding the area of composite figures. I'm going to work through the first two examples with you, and then for the remaining examples, I will encourage you to pause, work it out yourself, and then check to see my answers. There's a few problems at the end that I will work on with you just to remind you of the formulas, and then when we get to sectors of a circle at the very end, I'll show you how to compute those as well. All right, so when we look at this, we notice there are two shapes. The first shape that's pretty obvious to everybody is this rectangle. So my very first job is to find the area of this rectangle. That is something that we should remember from 6th grade. If not, remember that the area of a rectangle is very simply length times width. So in this case, I'm like I said, very simply just going to take 20 times 25. And when I take 20 times 25, I get 5. And then I also have this portion over here. This portion over here is a semicircle. Well, we just did an entire unit knowing that the area of a circle is pi r squared. The very first comment that kids tell me is that they don't have the radius to this, and you actually do. You have it in two different places. First of all, we know that the diameter is 25 because it's going to be the same length as this side. Or we have this dimension right here telling me that from this line to the edge of the circle is 12.5 centimeters. So you can find that information from either point. When I get here, we just go through all the steps that we did before, and we say pi times the radius squared. So that means I need to take 12.5 and square it. And then I need to take that times pi, and that gives me 490.63, and I'm rounding that there to the nearest hundredth. So I know that the area of this one is 500. The area of the semicircle is 490.63. So I just need to add those together. 500 plus 490 and 63 hundredths is going to be 990 and 63 hundredths centimeters squared for area. So I now know that the area of this composite shape is that. What if my composite shape isn't made of a semicircle, but it's made of a square and a triangle? Well, remember that the formula to find the area to a triangle is 1/2 the length of the base times the height, or base times height divided by 2. When I look at this, I know that the length of the base is going to be the same as the length of this side here. So the base is going to be 11 1/10. I know that the height of the triangle, which is right here, and it doesn't look like it because the triangle looks like it's laying on its side, but this is the height, that is 11.4. Okay? Then I also have this 1/2 out here. So I'm going to take all of that, I'm going to multiply it all together, and I get 63 and 27/100. That is just the triangle portion. Now I need to go back to the rectangle portion here and find its area, which would be 11.1 times 11.1. I need to verify, but I'm pretty sure it was a square. Yep. And when I get that answer, I get 123 and 21/100. So now, just like the last one, to find composite shapes, I need to add these two together. So I'm going to take this one plus that one. So I'm going to take 123 and 21/100 plus 63 and 27/100, and I get a total of 186 and 48/100 centimeters squared again. When you get to a problem that you're not really sure about, just take a step back and look at it. In this case, I have a rectangle, and I also have a circle. Now this circle happens to not go the entire length of the rectangle, but I can still find that. At this point, pause, then come back and see if you got the right answer. So I'm going to find the area of these two different shapes. When I find the area of these two different shapes, the area of this one is 108 centimeters squared, and the area of this one is 25 and 12/100 centimeters squared. Now I just need to add those two together, and I get 133 and 12/100 centimeters squared. Give yourself a nice pat on the back if you got that one right. Alright, so now I'm going to tell you to find the area of the shaded region and the shaded region only. For some people, their eyes automatically see this and say, hey, that's just a giant square or a giant rectangle with something cut out from the inside. How do I find the area of that for some people, because they can't necessarily see that right away? Well, just like you have a sheet of paper and you're going to cut the holes out, when I cut, that's the same as subtracting something. So that's exactly what I'm going to do here. First thing I'm going to do is find the area of the large square. To find the area of the large square, I need to take the length, we'll say 13, times the width, which I need to add these two together. So that's 8, 9, 10, 11, and then each half here would make 12. So that would be 13 times 12. When I take 13 times 12, I get 156 meters squared. Now that's the large square. What am I going to have to do is I'm going to have to subtract all these little squares from it. So when I get here, figure A, I need to take 3 times 3.5 to find the area of this one. When I do that, I get 10.5. Figure B has the exact same dimensions, so it's also 10.5. And figure C is 3 by 3, so that's only going to be 9. I can do this in two different ways. I can subtract each of these individually and take 156 minus 10.5, and then that answer minus 10.5, and then that answer minus 9. Or I can add all of these up, which would be 30 in this case, and subtract it from that. And that's what I'm going to do, just because I like the nice pieces to work with. So I'm going to take the large gray square. If that whole thing was colored in gray and there were no holes, it would be 156 meters squared. And I'm going to subtract the 30 meters squared from these three little pieces. And when I do that, I get a total of 126 meters squared. You try this one on your own. Go ahead and hit pause and see if you can come up with the answer. Alright, hopefully when you did this one, you found out that your large region had an area of approximately 70, had an area of 42 and 34/100 meters squared, and that the small area was 10.2 meters squared, and when you subtracted them, you got 32 and 14/100 meters squared. Alright, same idea for this problem, except you have two different shaped pieces inside here. You have a semicircle and you have a triangle. I'm going to, no, thought I could. I'm just going to undo that then. So what I have to do here first is find the area of this larger section and subtract those two smaller sections. Go ahead and hit pause and come up with your answer. Again, the large section here is going to be 10 times 11, which is 110 centimeters squared. Hopefully you got that for the large one. For the semicircle, you would have gotten 12 and 56/100 centimeters squared. And for the triangle, you would have gotten 10 centimeters squared if you followed all of the directions. Then you just take this 110 and subtract these two other pieces from that, and you would have a final answer of 87 and 44/100 centimeters squared. All right, in this example, I am not subtracting, however, I am adding. I have to look at this as two different figures. Go ahead and pause, come back when you have your answer. In this example, I have the rectangle on the bottom, which would be 352 centimeters squared when I multiply length times width. And for this triangle up here, I would get 336 centimeters squared when I take half the base times the height. And since this is adding and not subtracting, I would add these two together and get 688 centimeters squared. Again, if you got that one, give yourself a nice pat on the back. All right, this problem, there are two different ways to solve it. You can either use it as an adding problem, where I take this shape and add that one to it, or a subtracting problem, where I do this entire shape and subtract what's missing. Go ahead, pause, come back when you have an answer. In this answer, you should have had your rectangle in the for the adding portion of this. The rectangle would be 16 yards squared, and the triangle would be 4 yards squared. So altogether it would be 20 yards squared. If you did the subtracting, you would have had the rectangle at 24 yards squared, and that remaining little triangle would be, again, 4 yards squared, and you would have subtracted those two to yield the same answer. All right, this one is always an interesting question for our students. They seem to struggle with it, and then when we go over it, they realize it really wasn't that bad. So here we have Mrs. Dummer. Mrs. Dummer has a pool. Mr. Dummer, sorry. He is a 7th grade teacher at Cottage Grove Middle. Mr. Dummer has a circular pool with a radius of 12 feet. They plan on installing a 4-foot wide walkway around the pool. So this blue part is where the water is, and this is the walkway they want to install. We want to know what will be the area of just the walkway. So in this question, you have two circles. You have the large circle and the small circle. To find the area of the large circle, you have to use the formula A equals pi r squared. And then you have the small circle, which is where the pool is. A equals pi r squared. Go ahead and pause, solve this one, and then come back. If you happen to have been stuck on this problem, one of the things you are stuck on is probably where we put these labels. If I was to have turned this a little bit and put the 4-foot notification down here, the label down here, most kids would have said, hey, wait, from here then to here, let's do that in a different color, from here to here, that's 16 feet. So then you would have known that your radius for this was 16 squared. So pi times 16 squared equals the area, which would equal 256 pi. Then my small circle here, most people would have gotten as 12. So we would have had 12 squared, which is 144 pi. And then I could subtract those, which would give me 112 pi, or 351 and 68 hundredths of a foot squared. This one tends to be complicated for students every year, so if you got this one, give yourself a nice pat on the back. All right, for this problem, go ahead, take a minute, solve it, and when you come back, all I'm going to do is just give you the answer. The answer to this problem was B. Make sure you were paying attention to that. This one told me what the area was. So I needed to plug area in here and work backward. The answer to number 11, I'm going to give you in just a minute, if I can give you all of this. So the radius is 6. You have to find the circumference. You are looking for the circumference of this problem. And the circumference is A. Remember, circumference is just the diameter times pi. So if the radius is 6, you double it. All right, this problem is a sector problem. It is really this easy. I want to know what half of this area is. So I need to find the area of the whole circle, and it tells me the radius is 4. And then I need to cut it in half. When I do that, I get this for an answer. This is something you would get on your calculator. However, that pi key right there is what throws us off, because I shouldn't have that in my problem. Question number 13. You're going to do the exact same thing, except I only want 1/3. And if I only want 1/3, I need to cut it in 3 parts or divide it by 3. Oh, if you didn't pause that one, I didn't give you enough time. But that would have been your answer. So just make sure that when you are finding the area, make sure you know what you're doing. Are you adding? Are you subtracting? Do you need all of it or just part of it? And if not, you can either multiply by a fractions or add and subtract.